Welcome students for the chemistry lecture. You have finished up your first semester, and in the first semester you have studied chemistry paper number 1. Name of that paper inorganic chemistry, and paper number 2, that is the organic chemistry. And you have entered by completing your examinations of semester first into the semester second. And here I am concerned with the paper number 3, chemistry paper number 3. The name of that paper, physical chemistry, and the course of this physical chemistry, it is denoted by D.Sc. 3B. It has here 2 credits and 30 lectures. All of you know, due to the Corona-19 pandemic condition, we have to engage our lectures by online mode, and I know you are able to study with online mode. Again, stay in your home, be safe and kept corona away from you. At first, I will introduce you the chemistry paper number 3. Name of the paper, physical chemistry. It has 2 credits and 30 lectures. The first unit of this paper, it is the chemical energetics, and this chemical energetics, it is divided into 2 parts. Part A, it deals with thermodynamics, and you know thermodynamics, it is related with the conversion of heat energy into different other forms of energies. And all of you are well familiar with the first law of thermodynamics, second law of thermodynamics, and in the part A you have to learn the basic concepts of thermodynamics, first law of thermodynamics, spontaneous and non-spontaneous processes with examples. Then what are the different statements of second law of thermodynamics, and what is the physical significance of the second law of thermodynamics? Then Carnot cycle and its efficiency. Then you have to study what is entropy, physical significance of entropy, statement of third law of thermodynamics, and calculation of absolute entropies of substances. These are the subpoints that are included in the part A of chemical energetics, and that part A, it is the thermodynamics, and this is very simple topic. Then we deal with the second point, that is the point B, thermochemistry. And in this thermochemistry, you have to learn important principles and definitions of thermochemistry, concept of standard state and standard enthalpies of formation, integral and differential enthalpies of solution and dilution, calculation of bond energy, bond dissociation energy, and resonance energy from thermochemical data. Then variation of enthalpy of a reaction with temperature and Kirchhoff's law. Again, this chapter, it is divided into 2 parts. Part A, it deals with the study of thermodynamics, including basic terms and first law, second law, and third law. And remember, the part B, this deals with the thermochemistry, important principles and definitions of thermochemistry, concept of standard state of enthalpies of formation, integral and differential enthalpies of solution, and calculation of bond energies and bond dissociation energy and resonance energy from thermochemical data. These are the few points included in the thermochemistry, and we have to finish up this unit first within 10 lectures. Okay, this is the unit number 1. Then I will introduce you the second unit for paper number 3. The name of that second unit, it is a chemical equilibrium. Here, chemical equilibrium means what? Then free energy change in a chemical reaction, thermodynamic derivation of law of chemical equilibrium, distinction between delta G and delta G0, late Chatelier's principle, relationship between Kp, Kc and Kx, that is Kp, it is equilibrium constant for gaseous reaction, Kc, it is the equilibrium constant of solutions or reactants, they are in a liquid state, and Kx, it is the equilibrium constant when we consider the mole fractions of the reactions, or it is also termed as the solubility product for reactions involving ideal gases. And here second unit, it is deleted from the exam point of view. Here still you have to study this unit. Then I will introduce you the unit number 3, and the name of that unit is kinetic theory of gases, and this unit we have to finish within 7 lectures. This consists of subpoints as postulates or assumptions of kinetic theory of gases and derivation of the kinetic gas equation, ideal and non-ideal gases, derivation of real gases, deviations of real gases from ideal behavior, compressibility factor and causes of deviation. Then the next point, here it is van der Waals equation of state for real gases, explanation of real gas behavior by van der Waals equation. Then what is the boil temperature? Then critical phenomenon, then pressure volume isotherms of real gases. It is also called as the Andrews isotherms for CO2 gas. Then continuity of a state, critical constants and their calculation from van der Waals equation. Then the next point, it deals with the Maxwell-Boltzmann distribution law of molecular velocities and molecular energies. Here and their importance, the temperature dependence of these distributions, then most probable average and root mean square velocities, etc. Here, the kinetic theory of gases already you have studied in the last year, that means in the 12th science. This chapter, it is also very easy chapter, and all of you are well familiar with the assumptions of kinetic theory of gases. In this chapter, you have to study what are the ideal gases, what are the real gases, and how and why they deviate from each other. That means real gases show deviations from ideal gases. And the ideal gases are the gases which obeys the ideal gas laws. And all of you know the ideal gas laws are the Boyle's law, Charles' law, Avogadro's law, and Graham's law of dissociation. Dissociation at the time of uh, teaching of this kinetic theory of gases, I will explain you all these laws. Simply, time being, remember that this chapter, it is also very interested chapter and very simple to understand. You will study this chapter very well. Then the next unit for your paper number 3, it is the chemical kinetics. And this chemical kinetics, it consists of the subpoints as what is the rate of reaction, definition and units of rate constant, factors affecting rate of reaction, and that factors are nature of reactant, concentration, pressure, temperature, and catalyst. Then the next point, order and molecularity of a reaction. Then zero order reaction, first order reaction, characteristics of first order reactions, and examples. Then the next point that you are going to learn, that is the pseudo unimolecular reactions and their examples. Then second order reaction, derivation of rate constant for equal and unequal concentrations of the reactants, characteristics of the second order reaction, determination of order of reaction, and for your study there are three methods for the determination of order of reaction. The first method, that is the integration method, second graphical method, and third half-life method. And the last point of this chapter, it is the theories of reaction rates, collision theory and activated complex theory of a biomolecular reactions, and comparison of the two theories, qualitative treatment only, and the numerical problems, that means the formulas that are involved in the study of this chapter. Depending on that formulas, you have to solve the problems. This is the syllabus of chemistry, paper number 3, physical chemistry. This is the introductory lecture. I have here introduced you the syllabus of paper number 3, physical chemistry, and the books that you are going to refer. You may buy one or two books here, as the first book, Principles of Physical Chemistry by Puri, Sharma and Pathania. This book, it is of Vishal publication and it is the 44th edition. Then the another book that you may refer, that is the Advanced Physical Chemistry, written by Gurudeep Raj, and it is published by Goyal Publication House. Then you may refer this Essentials of Physical Chemistry by Bhal Tuli. Then the textbook of Physical Chemistry. Then Essentials. Okay, you may buy or you may refer any one or any two, or you may like the books. Our textbook, it is written by the Dr. S.K. Naik Professor A.N. Yadav, Dr. F.R. More, and A.R. Suple. And this book, it is a Phadke Prakashan. There is also a Nirali Prakashan book. You may refer textbooks. Then let us begin with the introductory part of the thermodynamics and some basic concepts of the thermodynamics. All of you know thermodynamics basically it deals with the study of transformation of heat energy into different types of energies. And all of you know there are different types of energies as chemical energy, mechanical energy, wind energy, solar energy, photo energy. And remember, all these energies are quite distinct and different from each other. And the thermodynamics, this is the branch of chemistry, especially physical chemistry. It deals with the study of interconversion of heat into other forms of energies. And this thermodynamics, it is studied with the help of laws. And remember, all these laws are based on human observations and they are uh, proved with the help of mathematical formulas. That means all these laws they are important in our daily life also, and it is quite interesting chapter. Here again all of you know the first law of thermodynamics, it deals with the conservation of energy, and conservation of energy means no loss of energy, no gain of energy. And the statement of first law of thermodynamics, it is the energy neither created nor destroyed, but it is converted into one form of energy, it get converted into another form of energy. Very simple one. This is the statement of first law of thermodynamics. Then how mathematically the first law of thermodynamics it is expressed. And while studying this thermodynamics, which are the terms that we oftenly use, that terms are what is energy, what is work, what is system, what is process, what are the different types of processes, and we will see at the time of uh, studying this chapter. Then the second point here, spontaneous and non-spontaneous processes. Here spontaneous processes are the processes which occurs without addition of external energy, without aid of external energy. That means to occur that process we don't have to force to occur that reaction, it takes place on its own accord. Such processes, such reactions are called as spontaneous reactions, and opposite of this non-spontaneous processes. That means non-spontaneous processes occurs with addition of external energy or external agency. Next time we will see the proper examples of spontaneous, non-spontaneous processes. Here I will explain you the one example of spontaneous process. Suppose we have iron bar and it is heated at one end. Then all of you know the heat it will get transferred from hot end to cold end, and this is a natural process, the flow of heat from hot end to the cold end. This is the natural process, and opposite of this, the flow of heat from cold end to hot end, and obviously this is the non-spontaneous process. Okay, I mean at the time of next lecture I will explain you once again the basic terms that are oftenly used in the study of thermodynamics and mathematical expression of the first law, spontaneous, non-spontaneous reactions. Okay, thank you.